Okay, today we are going to explain what is meltdown. So meltdown is one of the most significant and most, most widely spread and most vulnerable CPU vulnerabilities have ever existed in the world, and we're gonna to take a look at what exactly is meltdown today. So before starting to talk about meltdown, I would like to introduce a story for you, and this is actually inspired by a book that I've read, and I'm gonna leave the reference to the book later. So here's the story. The story is, you got a room. It's something like this. Just imagine this is a room, and then okay, so inside the room there is 3 controls. There are 3 switches. So I was draw it like this. So this is a control 1, and I'm gonna paste it. This is control 2, and then this is the control 3. Yeah, and then on the other side we got 3 light bulbs. So it is something like this. Okay, so this is a light bulb 1. This is the light bulb 2, and this is the light bulb 3. And they're actually connected. So the control 1 actually connecting and controlling light bulb 1. Control 2 controls light bulb 2, and control 3 controls light bulb 3. And all of these make sense at the moment. And there's and you are actually inside of the room, and you can actually have access to the 3 controls inside of the room. And then you just your goal is you wanted to know that which control the which light bulb, which control is associated with which light bulb outside of the rooms. So here's the interesting thing. So we said that control 1 is actually associated with the light bulb 1, and we said that the light bulb 2, the control 2 is associated with the light bulb 2, light bulb 3 is and so on and so forth. But this is actually not the whole story. The whole story is, there is also another chance that the control 1 is controlling light bulb 2, and the control 1 might also control light bulb 3, and so on and so forth. So your goal is trying to figure it out which control is actually associated with which light bulb. But you can only have one chance to go out of the room to take a look of it. So you have to be controlling so you only have one chance to control the 3 3 switches, and you also only have one chance to go off the room and take a look for the light bulb. But you have to be but your goal is going outside for only once, but you actually can understand which switch is actually associated with which light bulb. So this is your goal. And it actually sounds impossible to be achieved. And why is that? It is because if you're just going out one time, and you have, it is very, it is certainly that you're always gonna have two light bulbs that is have they are going to have the same status. So it's either it is either this one is on, this one is off, and this one is off, and you can only differentiate one of them, right? You can only differentiate the one that is on. You cannot actually differentiate the two that is off. Given that the status is only two, you're actually impossible to just figure it out the associations of the light bulbs by going out just one. But your goal is just, but that is your goal. So how can you achieve that? So the way that you can achieve it is probably introducing one more parameters so that it can be, so that the light bulb, the status of the light bulb can be differentiated. So instead of one of them being on and two of them being off, you probably need one more parameters so that one of them can be differentiated by the second parameters, right? So this is probably the only way to solve this problem. So here's the thing, how to solve this problem by introducing one more parameters. Is there any parameters that are available for us to introduce to? Is there any parameters for us to introduce? And it seems no, but it seems no if you're thinking the problem ordinary, if you are having an ordinary thought about the problems, you're never gonna figure it out the way to solve this problem, because this is mathematically impossible. But if you try to think of the box, and you probably is gonna notice that light bulbs not only have one parameters, which is the the on and off. Which is actually illumination, or the illumination, but also the temperature. Oh, it's not only the brightness, but also the temperature. So this is the parameters available. There are brightness. What's the second one? The second one is temperature. So the thing is, you can actually you can actually control the durations of the on and off of the light bulb and create a difference in temperature so that you can differentiate the two light bulbs that are off. And this is the goal, and this is a key to solve the problem. So what you're gonna do is you're gonna turn on one light bulb, which is this one, apparently, and this is gonna be the only light bulb that's gonna turn on after going outside of the room. But for the remaining two light bulbs, there are some tricky things happening right here. So for the first light bulb, for the first light bulb, you can actually leave it off through all the time, and so the temperature of it is gonna be cold. However, for the second light bulb, it is also turned off, but it is turned off at the moment when you is about to go outside of the room. So its temperature is gonna be warm, but it is also off. So when you go outside of the room, you now actually have two parameters for you to differentiate the three light bulbs, and this is necessary for you to recognize or differentiate each of the light bulbs. So and this is the key to solve this problem. So this is so this is how you can solve this IQ problem. And interestingly, the same methodologies can be used in Meltdown attacks, and it is actually adopted by the cybersecurity researchers, and it actually create a very sophisticated, very brilliant, very tricky solutions to the CPU protection mechanisms, and we're going to talk about this later.